AWS Loft Talks.
I'm Dan Chuparkoff. I'm VP of Product at Civis Analytics. Civis is a company in Chicago and DC. We've got about 85 employees. We do data science services, and we have a data science product platform as well. So what I'm going to talk to you today about is how we decided to put that platform on top of AWS components, and AWS is the core underneath all the services that we offer as well. A tiny bit about data science in general as well. So we're Civis Analytics, and we started about 3.5 years ago. At the beginning of our life, for like the first year and a half or so, sadly we only had one client. Fortunately, though, that one client was Obama, so it was pretty cool. So this is the output of some of our work. Our founding members were part of the campaign team. They were looking at Obama's resource spend during the campaign, trying to figure out which states he should spend his energy trying to convert, right? Ohio is the answer. Anyway, so after the election, it went really well. We realized we did some data science stuff that was really, really good. Our algorithms were really tight. We got really, really, really close to predicting the election results. Not just at the end, but every single day. Every single day we would run 60,000 simulations to predict the outcome of the voting and tell Obama where to go that next day, right? So really, really hard problem. And at the end of that, what we realized is that Obama just had a customer acquisition problem. He was just looking for voters that would choose him, right? And every company that's looking for customers has that same exact problem. So we're trying to take what we did for that campaign and turn it into a platform that helps anybody solve customer acquisition challenges or other data science problems too. Let me back up a little bit and start at the beginning. So I'm here to talk about sort of the data science revolution, and it started actually 12,000 years ago. Before this, there were hunter-gatherers all over. People just wandered, and they discovered agriculture. Huge revolution, the agricultural revolution, and it changed the world for sure. About 10,000 years after that, the Industrial Revolution came. Again, the world changed, right? And this enabled technology for the revolution. Next, first transistor. The technology revolution started with the first transistor, and that enabled computing at huge speeds and massive storage and all that stuff. And that has resulted in the fourth revolution, which is the data revolution. So data science, we're all here talking about big data. It's all over the news. A lot of people think of data science as that statistics part or the analytics thing that the analysis team does. Data science and statistics are not the same thing. Data science is solving real problems with your production flow. If your analysis team is off in a corner somewhere doing quarterly reports and just showing people, you're doing it wrong, right? If your team is helping you do the work your company is actually doing, so if your data science team is integrated with trying to find new customers or reach the uninsured people in America and give them information about programs, or you're at a university and you're reducing student dropouts, you're improving employee retention at a large organization, right? All of those are the kinds of data science challenges that people are trying to solve today. And the cool thing is these are all exactly the same problem. So all of these are a list of people, right? And then some amount of those people met this case. And then data science looks at that huge list of people and just looks at the people that haven't converted yet, haven't dropped out, haven't gotten insurance, and helps you figure out what are the patterns in there? How can you reach the employees that are most likely to leave and intervene, right? How can you find new customers that are most likely to choose you and reach out to them and disregard the people that are not going to choose you? So that's where data science comes in. All of this is the same problem. You're just prioritizing lists of possibilities and optimizing the resources against that. Here's how you break that down. Some people think of data science as that's the thing the modeling people do, right? Or that's that one analysis part in this big long chain of data production. It's really a series of very distinct steps. And if it's all integrated together, you'll be making really, really good decisions, and pretty soon you end up going from step to step in real time and making constant real-time data science-driven decisions. So these are the 6 steps. I'll drill into them as much time as I have before. And so measuring all the data. So most of you are collecting data. We've got log files, we've got customer data, we've got all kinds of things. Then your analysis team tries to pull them together. Then you start drilling into that data to understand what you have to work with. Then you start running modeling to look for predictive patterns in the data. Once you find those patterns, do something about it, right? Like connect that data directly to the thing that's reaching out to your customers, right? Don't just create a report card that you share with your team that says you're not doing a good enough job, right? Connect it to Silverpop or ExactTarget or whatever you're using to reach out to people. And finally, connect all of that to a thing that will allow your whole team to interact with the data and the insights and how it's running your production. These are the 6 steps of the data science workflow. We've built a product at Civis Analytics that's wrapped around those 6 steps. So what we're trying to do is help people do data science in a very structured way from end to end without them having to figure out like how to build those steps or how to pick which AWS things they need or how to run modeling like if they've never done it before. Essentially, it's here to help you do end-to-end data science. The next thing is it's all built on AWS components, right? So it's all on Redshift. Amazon is great because they give you this pile of Legos, right? Like they have all kinds of things that you can build anything you want with it. So we've got a bunch of Legos, but the thing that's troublesome sometimes when you're first getting into it is that huge pile of Legos can be overwhelming, right? You can build anything with it. And actually, this girl looks like she's having a really fun time. But when I was drowning in AWS components, I was having slightly less fun than this. What we've tried to do at Civis is try to take that pile of Legos and build a really cool pirate ship out of it, right? So if you're trying to build a cool pirate ship out of Amazon Legos, we can help you do that, right? I'm going to tell you what Legos we picked. This is how to build a data science pirate ship. So these are the 6 things we picked that are the core of our solution. There's some other things that we also use, but these are the fundamental 6 pieces. We've got Redshift, EC2, S3, Dynamo, RDS, and EMR. And I'll show you how those all fit together. I have this data science workflow. I realize, hey, there's these 6 things that I'm trying to do. The next thing I realize is, hey, it's not actually an end-to-end thing. It's not a linear flow at all. It's a circle. It just keeps going around and around. After I do stuff, I get more data, and I feed that back into the system. It constantly goes around. Then I looked at those AWS things, and I realized I have some data, and I have S3 and Dynamo and so on, and they're all sort of floating around Redshift, and I realized those 2 pictures look a lot alike. So what we did was we helped figure out how the data science workflow is going to interact with those components. This is probably my most important slide. This is essentially our data science on AWS architecture slide in a simplified way. We start with data at the beginning. All of you are collecting lots of data in lots of different ways, right? Our platform will help you connect all of those things in a unified way. You can run automatic synchronization. You can connect remotely to data, so you're not making huge copies of huge piles of data. You can upload files, you can sync with things like Salesforce and so on. So you start with a bunch of data, and the first thing you have to do is unify it, pull it all together so you can run models against large amounts of data. S3 helps us do that, right? Like we use S3 as a staging place as we're trying to aggregate things together. S3 is the tool that helps us do that. Once we have it in S3, we start building a Redshift core around what you're using. So Redshift is the central component of our system. It helps you pull all of your data together so that when you're running modeling, you're running it against this array of stuff. Once you have a bunch of tables and CSV files uploaded and remote databases synced, the next thing you need to do is sort of link it all together. So that if you have people in Salesforce and people in your own customer database, you can't run modeling to see which of your leads are likely to become customers unless you know which people are in both databases. So when we were on the Obama campaign, we got really, really good at matching people between databases, right? So we know that the Dan Chuparkoff that used to live in San Francisco is the same as the Daniel Chuparkoff that lives in Chicago right now, right? So we're really good at matching people between disparate data stores, right? And we do that using DynamoDB. Because we're doing that in small batches, small iterative batches, and they're generally not huge 20 billion row tables, using something like EMR is not worth the cost. So DynamoDB helps us do that data management in small, meaningful batches at low cost. Once we get into predictive modeling, that's where we pull in things like EMR. Sometimes we're scoring tens of millions of rows, sometimes we're scoring billions of rows. And when we do that, sometimes it could take, it could take 3 weeks to run. When you're trying to tell Obama where to go tomorrow, you can't wait 3 weeks for that to run, right? So EMR allows us to scale up and down dynamically so that when we're running some big scoring operation, we can blow up the nodes a little bit, get some extra resources, and then shut them back down when we're done. Finally, EC2. We use EC2 to house, we serve up reports in Tableau. We also have D3 code. We run EC2 to serve up a virtual instance of your Tableau server so that everyone in your organization can see the data. And then finally, RDS. We use RDS for sharing reports in an automated way. So once you have a bunch of analysis done on your customer set and then you get new data the next day, we can use RDS to schedule the distribution of the information as it spreads throughout your organization. Finally, all of that starts generating more data and we keep going around the circle.
AWS Loft Talks.